Hi you guys. So in this video we'll continue working on chapter 3. This is section 3.3. It's about division of polynomials, and we're going to take a look at the remainder theorem and the factor theorem as well. Now when I say division of polynomials, what comes to mind right away is basically a function on top and a function on the bottom on your right. If you remember, I said that a function f of x is a polynomial when it takes on this form from the previous section, which is a subset n x to the n power plus a n minus 1 x to the power of n minus 1 plus dot 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 a1 x to the first power plus a0, right? This is a standard form of a polynomial in a generic way. So the idea here is that we are going to look at the function, let's call it h of x, where h is f of x over g of x, right? So what I'm saying here basically is that h is a division between two functions. One function that is a polynomial divided by another function that also is a polynomial, and those together is h of x, yes? Now, let me give you a standard setup that we could use to look at these types of function. So say your function x, f of x, is a combination of multiplications and additions. So I'm basically saying that the function f of x is dx, which is a function, multiplied by qx, and then you add rx to it. Yeah, so I'm basically saying you have two functions multiplied plus a number, and this is what my f of x is. Again, f of x is a polynomial. I'm just writing it in this form to point out a certain aspect of this section. All right, now, so if I want you to divide f of x by d of x, right? So these two are not equal. I'm just saying this is what I want to do, because that's basically what division is. When you're dividing two polynomials, you're not just going to divide it by any function. I'm going to ask you to divide it by one of the zeros, and by zeros I mean the solutions, like we discussed in the previous section. So if I want to divide f of x by d of x, and notice that d of x is inside the function, which means it was initially one of the factored answers in here, right? So if you divide f of x by d of x, what is that going to equal? What's going to happen here? Again, this whole thing is f of x. That means the whole thing is getting divided by d of x, correct? Okay, so when you grab this portion right here, where you have d of x and q of x, and you divide it by d of x, what's going to happen? You're going to end up with d of x times q of x over d of x, right? Where this d of x and that d of x cancel. So really the result is just q of x plus r of x, also divided by d of x, right? So the final solution ends up being q of x, which is what's left of that multiplication after you've canceled out the d of x, and r of x over d of x. Now I'm going to explain to you what this means. When it comes to division of polynomials, this is what you need to know. F of x is the dividend. This is what you're dividing, right? D of x is the divisor. This is a polynomial I'm going to give you to divide by, all right? Now, when you divide a function by something, you're basically dividing that something out of the function, which kind of makes sense. But once you do that, you're going to end up with the quotient, which is basically the answer of that division, and the remainder. So the final result is going to give you just a quotient, and then the remainder divided by that d of x, because this division technically wasn't solved yet. We didn't continue dividing. We had to stop because this number is not divisible by it. Make sense? So this is the idea here. Now, the methods of dividing is actually going to be very familiar to you guys, or at least I hope it should be. This is a level of math that I think in school you should have seen in maybe the 5th grade. I don't know. which is the long division. Are you guys familiar with this shape? So what do? For the long division, over here, you write down what you are dividing by. Over here, you write down what you're dividing. And over here is where the results are going to get entered, right? This is where your answer is going to be. And if you end up with a remainder, that means that the final part of this long line that you're going to solve is not going to be 0, right? It's going to be a number. That would be your remainder. Same thing. But instead of having normal numbers or really big numbers that you need to divide, we're going to have functions in here. So let me give you an example and show you how this looks like when you're dealing with functions. Alright, so here's an example for you. The function I want you to divide is the following. You have f of x being 2x cubed, let me move it a little bit, 2x cubed minus 11x squared plus 13x plus 15. So this is a polynomial to what degree? To the third degree. As you can see, it's positive. Now, what I want you to divide this by, so divide by, and let's see, divided by 2x minus 5. Yes? So really, to rewrite this in terms that look familiar to you guys, it would look like this. Divided by 2x minus 5. This is what I'm saying. This is what I'm asking you to do. Grab this and divide this whole thing by it. Alright? So I'm going to do it here. Now, again, we said what I'm dividing goes in here, right? So it's 2x cubed minus 11x squared plus 13x and plus 15, right out of room. There. Okay? And then we're dividing by 2x minus 5. Alright, so let's start. Now here's the first thing you need to do. You need to look at the x term because that's the one that's important to you. The 5 being added to it, that's just something you add in the aftermath. So you don't have to worry about it too much. What you need to do is look at the 2x over here and look at the 2x cubed. How do you turn this 2x into 2x cubed? I'm going to give you a second to think about that. But the answer is x squared. If I multiply this by x squared, then 2x becomes 2x cubed, correct? So that's what I'm going to multiply by. Now I know I said ignore the 5, but once you're done, figure out what the number you're going to multiply by is. Now you multiply the whole thing. So I'm gonna grab the the x squared, multiply it times 2x, and you end up with 2x cubed, right? But you're not done. You need to multiply by the 5 as well. So x squared minus 5 multiplied together, that gives you negative 5x squared. Right. So you have this term and that term. Those are the ones you're adding. Okay, so, oh, I'm sorry, I said adding. We're subtracting. Alright, so those are the ones you're subtracting. Now, when we subtract these two terms, what's going to happen? 2x cubed are going to cancel completely, yes? But I just want to note something. I'm going to put these parentheses in here to demonstrate why the answer is going to come out the way it does. Right? So anyway, negative gets multiplied inside the parenthesis. 2x cubed becomes negative, so they cancel out. This is 0. And the negative multiplied by the 5, which is also negative, turns it positive, which is why when we subtract these two, the total is not going to be negative 16, it's going to be negative 6, right? So, minus 6x squared. So, as you saw, we did this one, we did that one, and now we're stuck here. So once you're done with this, what I need you to do is grab the next term you still haven't touched. So notice, we subtracted these two. That means I need to go to the third one. So this one right here, grab it and write it down next to the negative 6. So that's 13x. Right? So 13x goes right here. Now I do the cycle again. I'm going to look at my divisor, look at the x, so I'm going to look at the 6x squared here, negative 6x squared, and the positive 2x, and think, how do I turn this 2x into 6x squared? So for x to become x squared, you're multiplying by an x, right? And for the 2 to become 3, you're going to multiply by, sorry, to become 6, you're going to multiply by 3, right? So 2 times 3 gives you 6, and the x is going to give you x squared, therefore you multiply by 3x. But wait, 6 is negative. That means the 3 has to be negative. I'm multiplying by negative 3x. Alright? Now, since I multiply by negative 3x, this negative 3x is going to get multiplied to the whole function here. So the 2x and the negative 5. So the negative 3 times the positive 2x is going to give you negative 6x squared, like we wanted. And the negative 3x times negative 5 is going to give you a positive 15x, right? Now, we are going to subtract again. Now, parentheses, just so you won't forget. This sign flips that one and flips this one. So the 15x becomes negative and the 6x becomes positive. So positive 6x squared and negative 6x squared are going to cancel, so they add up to 0. Plus or minus positive 13 and negative 15 is going to give you negative 2x. Alright, so now we have a negative 2x. And we do the same step we did before. You grab the 15, move it all the way down, and you add 15 right here. So now we have negative 2x plus 15. This is the last one we need to worry about. Now, think about these two. I have 2x and negative 2x. What do I need to multiply 2x by to get negative 2x? As far as the numbers, the values are concerned, nothing, because you already have 2x. The only thing you need to worry about is the sign, so I'm just going to multiply it by a negative. Therefore, it's negative 1. Now, negative 1 multiplied times this whole thing gives you what? Negative 2x, right? And a positive 5. Correct? Now, I need to do a subtraction between the two. This goes in a pair of parentheses, which means this turns positive, so the addition is 0, or the difference is 0. And this turns negative, so the difference between those two is positive 10. Now, is there anything else I can bring it down? No. Anything else you can do? Not unless you want to go into decimals, but even then you have x and you don't have x here, so really you have to stop. This right here is your remainder. Now, before I continue to explain what is going on here, I want to go back up a little bit so you can see the original form I wrote down. So, f of x, the function we divided. D of x, what we divided by. Now for the result, it gave you what? Quotient. I said the quotient is the answer, which is this right here, plus a remainder of the function divided by the divisor, right? So since this is the quotient, this is what we're dividing, this is what we divided by, that means this is your remainder, right? So your final answer is going to be this right here. The x squared minus 3x minus 1. But you can't stop there. You have to add the remainder, otherwise you're neglecting that part of the equation. So you have to add the 10. But if I do it like this, what's the difference between this 1 and that, right? The difference is that this 10 is still to be divided. I can't divide it. So you write the divisor in the denominator still, because this one is yet to be divided. We finished these, this one's not complete yet, which is why the form looks like that. Q of x, which happens to be this part, plus the remainder over the divisor. Make sense? So this right here is the result of that division. I hope this made sense. I'm gonna show you guys a few more examples, so don't worry. But let me give you guys a few seconds to copy this down. So all you need to is just pause the video. I just don't want you guys running after me trying to catch a frame where I have the entire page showing and no hand, or my hand is not covering or moving. Alright, that should be enough. Okay, so this is the first page we just did, in case you need to copy the notes. Alright, now again, all of this is already in the note set. What's wrong? Blah. All of this is in the set of notes I upload to Blackboard. So you already have the solution set available to you. I just wanted to explain it and show you the work, hoping that this would make things a little smoother. Alright, now, let's do another one. 2. Here's another example. We have x to the 5th minus 3x to the 4th plus 12x to the first power minus 33. This is the function I want you to divide. And you're dividing it by this, x minus 3. Okay? So, this is my dividend. This is my divisor. Okay, so let's do that. We have the long division frame. X minus 3 goes in here, and my function is going to go in here. Now, as I write it, I want you guys to take a second and think, what looks strange about this? And I'll give you a hint. You have 1, 2, 3x terms when the power is actually to the 5th. So what does that tell you? What's happening here? What that should tell you is that you have a few values missing, right? You don't have x cubed and you don't have x squared. But that's actually a problem. Now, it won't affect the way you answer the question, so if you didn't write it, it probably give you the same answer, but it will confuse what the answer looks like, which is why I think you might as well just write it and get in the habit of writing it, because in long division, it won't affect you too much, but when we do synthetic division, it will. So, over here, you have x to the 4th. It's supposed to be followed by x to the 3rd. Since we don't have it, I'm going to write 0 times x to the 3rd, because that's technically what happened. It's just that you have a coefficient of 0 times that x, so it disappeared. Make sense? So, plus 0x squared, because again, that's not there. Now, x to the 1st we do have, so it's 12x, and then the number, which is the negative 33. Yeah? Now let's divide. Starting off with this one. How do you get x, focus on the x, how do you get x to equal x to the 5th? What do you need to multiply it by? I need something to multiply x by to get x to the 5th. Well, that one's easy, x to the 4th, right? So if I multiply x to the 4th times this whole pair, what happens? X to the 4th times x is x to the 5th. X to the 4th times negative 3 is negative 3x to the 4th. Okay? Now we do subtraction, parentheses, which means this is going to be negative and that one's going to be a positive. Okay, so the x to the 5th, x to the 5th cancel, 0, and the negative 3x to the 4th and the positive 3x to the 4th are going to cancel as well, so 0 plus 0. The answer is just 0 in that one. Okay, since we have nothing to add it to, we're going to grab this one and move it. Oops, that's 0. Oops, that one's 0 too. So the next one we're going to use is this one. Simple as that. Just skip over the rest. You go all the way to 12x. Alright? And since it's alone, I'm going to grab the 33 as well. Okay, so you bring down the 12x minus 33. So these two, everything here basically give you plus 0 so far. Nothing to worry about. And now we're starting off at this point. So 12x minus 33. Again, we're going to do the same thing. We have x. How do you get x to equal 12x? You multiply by 12. So we do that. Now, 12 times x is going to be 12x, and 12 times 3 is going to be what? Come on, you should know this. It's negative 36. Right? subtraction. Put the parentheses so you don't forget to change the signs. Now, positive 12x, negative 12x is 0. And a negative 33 minus a positive 36 gives you a positive 3 as the answer. So this right here is your remainder, correct? From this, you can tell me that the result of this division is x to the 4th plus 12. Yes? Are we done? You're missing one thing, the remainder. Plus 3 over x minus 3, because we technically haven't divided that 3 yet. And since you can't, you write it the way you see on the screen. Yeah? So that one was easy. It went a lot faster than I thought it would. Let's do more. And again, you guys, if you have questions or you don't understand something I wrote, send me an email to ask me a question, and it would help out if you tell me like the section number we're covering and the timestamp in the video. So right now, for example, as I'm talking, is 21 minutes and 20 seconds-ish, right? So just tell me at 21 minutes, 30 second-ish, you were talking about problem number 2. I didn't understand this part. Yeah? So that would help me pinpoint what you're talking about faster and answer you more accurately. Yeah? But anyway, so let's do one more before we move on to more fun problems. Okay, so here is question 3, or should I say example 3. Alright, in this one, I'm going to give you one that's a little bit more tricky, but not necessarily harder. Alright, ready? Here we go. We have 2x to the 3rd plus 2x squared minus 16x plus 32. And I want to divide it by x squared minus 3x plus 4. So I give you a 3rd degree divided by a 2nd degree. Now, again, long division. So, big line. Over here we have what we're dividing by. Right? That one. And over here, I'm going to write the function we're dividing. So, that is 2x cubed plus 2x squared minus 16x plus 32. Now, let's see. Grab the first one, 2x cubed, right? Okay. What do I multiply x squared by to get 2x cubed? Well, for an x to go from square to cube, you multiply by an x, right? And since the coefficient here is 1, and you want to get to 2, you're going to multiply by 2. So, 2x. So, you multiply this by 2x. Now, when you multiply the 2x in here, you need to multiply every term. Please always remember that. So, 2x times x squared is going to give you 2x cubed. 2x times negative 3x is going to give you negative 6x squared. And 2x times the 4 is going to give you positive 8x. Yes? So, subtraction, bare parentheses. Alright, so 2x minus 2x cubed. It gives you 0. This is cubed, that's cubed, they cancel. Alright, now 2x squared minus positive 6x squared, right? So basically, I am adding 2x squared and 6x squared. So the result is going to be a positive 8x squared. Now, negative 16x minus a positive. So these two negatives are not going to be influenced, and you are going to end up with, can you guess it? Since this is negative, this turns negative, we're adding. So 16 plus 8 is 24, and it's negative. Yeah? So we solved this one, it gave you a 0. We did the subtraction here, we did the subtraction here. So the next term you did not touch is that one. So I'm going to grab the 32 and move it down. plus 32. Now we do the same thing again. We have 8x squared, x squared. How do you get x squared to match 8x squared? I'm going to multiply it by what? 8, right? So plus 8, just the number 8. So 8 multiplied times x squared gives you 8x squared. 8 times 3x, and that's negative, gives you negative 24x. And 8 times positive 4 is going to give you a positive 32. Well, look at how nice this one is. Yeah? 8x squared, they're going to cancel. 0. Negative 24x, which turns positive after the submission, means they cancel. And this one also turns negative, which means they cancel. You subtracted the exact same thing from itself. So the result is 0. That means you have no remainder. This is as nice as it could get, because that means that the result of this division over here is simply 2x plus 8. That's it. No remainder, nothing to add and divide by stuff. Just that's the answer. Okay? Now here's a question. Why? Why didn't we get a remainder? That's because this is basically telling you that had you grabbed this original function right here, the cubic function, and you factored it, right, into 3 pairs, one of them would have been the answer we got. And the other 2 multiplied together is this quadratic that we divided by. Make sense? So we basically divided by the zeros of the function itself, which is why you got the result of, you got the remainder to be a 0. That's why. But anyway, so that was long division. Now let's try synthetic. Here we go. Oops. Here we go. Alright, so for this one, I'm going to show you guys the step, one step at a time. But before I start explaining what how synthetic division works, I need you guys to note something. That in the previous examples, in some of them, you had a quadratic as your divisor, and in another one, it was 2x minus 5, right? But when it comes to synthetic division, you can only use this method when I give you a specific type of divisor. What you're dividing by has to take a specific form. If it's not in that form, you can't use it. Make sense? So, and that form is this right here, x minus c. See this? C being a constant, it could be any number as long as it's a constant that you have in the domain of that function, right? So it doesn't matter what C is. But the divisor needs to look like this. It has to be in the form of x minus c, right? Now also note that if this is the case, that when you're dividing, c is the number you're going to be using. So let me give an example here just to show you the relation of how this looks. If I give you a function and say, I want you to divide this one, which is x cubed minus 13x squared plus 46x minus 49. That sounds nasty, right? Okay, and I want you to divide this by x minus 8. Can you look at this and tell me what my c is? If your answer was 8, you are correct. If your answer is negative 8, you're wrong. Okay? Why is that? Because the form, as you can see it, is in the form of x minus a number. So it's supposed to be a subtraction sign in there. It has to be a subtraction sign in there. Okay? So if I give you x minus 8, that means I'm saying c, in this case, equals 8. And if I gave you x plus 8, that means that this was actually x minus negative 8. Because again, the form needs to be subtraction. Which means that c in this case would be negative 8. Alright? So it has to be a subtraction for the c value to be positive, which is very similar to solving a 0 for x. If you remember, when we factor a function and you get, for example, x minus 1, and I say set it equal to 0, you remember that part? And you go, okay, negative 1 moves to that side, x equals positive 1. Same thing. It was subtraction on the inside of the parenthesis, but the final result ended up being positive. That's what I'm saying right here. The form says x minus c. So if you see subtraction inside the parentheses, c is indeed positive. If this is a plus, then it's going to be negative. Okay? So I need to stress this because that one mistake can ruin your entire problem. So make sure to notice the sign. Now, let's actually look at synthetic division and what it means. So this is like a side note over here. Yeah? Okay. So now let's do synthetic division. So when it comes to synthetic division, unlike long division, you're not going to write every single thing you see in the problem. All you're going to write is the signs and coefficients of the terms. Okay? So all you need is this little box right here. Okay? And in this little box, we're going to write down the c value, the number you have in your divisor. In this example, it's 8, right? So you see why it's important to know the sign, because if you got it wrong, you would be dividing by -8 instead of +8, and the entire thing would be incorrect. Make sense? So since I gave you x minus 8, that means over here you write down +8. Okay? So that was the divisor section. We're done. Now we need to do the function itself. So what I need you to do is grab the coefficient of every term and write them with spaces in between. All right? And leave enough room so that if the number has a negative sign, you won't mistake it for a number minus another number. Okay? So over here, for example, is x cubed. The coefficient over here is the number 1. So I just write down 1. Going to the next one. The coefficient over here is -13. So I'm going to leave room and then write -13. Okay? Next one is +46. So leave room, 46. The next one is -48. So leave room, -48. See how they're spaced out? I'm not adding or subtracting them. I'm just writing them in that order. Okay? Now, also note that you need to write down every single term of x you have. So in this one, the function I gave you is complete. You have x cubed, x squared, x to the first, and no x at all, right? But if I gave you some that didn't have, for example, x squared, then you'd have to write the 0 over here. Otherwise, you get it wrong. Make sense? So you need to account for every single x value the function could possibly have before you start doing this. Alright? But I'll do an example like that later on. Let's focus on this one for now. So we wrote down the number in the divisor over here. And we wrote down the coefficient of the function itself over here. Now we start doing the synthetic division process. Next thing you need to do is leave a little room and then draw a line. The room needs to be enough that you can write another row numbers. Okay? Okay. Now, first step, you grab the first number over here, aside from the one inside the box. The first number you see, which is 1. I'm going to draw an arrow that goes directly to the bottom and write down the 1 as an answer. 1. Goes all the way to the bottom. Alright? Now, next step, the number you started with, that's now in the bottom, I'm going to multiply it times this 8. Multiply. Yes? I'm multiplying it times that 8. So 1 times 8 is what? 8, right? The answer gets written right here. Alright? Now, between these two, I'm going to add. So 13 plus 8 is what? -5, right? Okay. Now, you grab the -5 and you multiply it times the 8. You do the same thing you did with that one. And the answer is going to be written right here. So -5 times 8 is what? -40, right? Okay. So now we have -40. I'm going to add these two. 46 positive minus 40, because we're adding them, so it's plus -40 basically, is going to be what? +6, right? Okay. Now you grab the 6, you multiply it times the 8 again. So 6 times 8 is what? 48. Now we have -49 plus 48, and the answer is going to be -1. This right here is your remainder. We're done. So this one is a lot easier. You just need to understand the setup. Once you get it, and with enough practice, you can do a problem like this in less than a minute. Long division takes a while because you actually need to multiply them out, but this one, not so much. As you saw, we're only using the numbers and we're doing it really quickly. So, now we need to translate what I just wrote, right? Do you know at the beginning how we wrote down the coefficient of the numbers? Well, that's exactly what we did here. These are the coefficient of the answer. So, the book recommends you start from the left side. Sorry. The book recommends you start from the left side and you assign the degree for each coefficient that is one less than the function you started with. Meaning, over here I have coefficient 1. That means it's going to be 1x squared. Right? So 1 less than the function we started with. And then we have negative 5. So it basically means it's going to be negative 5x, 1 less than that. And then plus 6, because the x to the 0 is not written, right? And then you write down minus 1 over x minus 8, because that's your remainder. And this is your answer, right? And this way is good, and if you feel comfortable using it, you can. Just, again, 1 less, since we're dividing by first degree, that means the degree of the function is going to drop by 1. So 1 less than the function you started with, and you assign the numbers to x's until you run out. So second, first, and then I ran out, so it's just 6. And then minus, because it was negative, or you can make it plus negative, it's up to you. I don't mind. So negative 1 over x minus 8, because that one still wasn't divided, it's a remainder. Okay? That's the book way. My way is very similar. I just usually recommend you start from the right side. This is clearly the remainder, right? So we'll do that. I just recommend you do this instead. You go, okay, so it's negative 1 over the divisor. This serves two purposes. One, you start from a point you already know. You don't have to try and force yourself to remember that you need to subtract 1 from the power before you start adding x. And you get writing the remainder out of the way, since that's the part people usually forget, or you forget to divide by what it is. So when you do it first, you usually make sure you get it right. So first thing, do the remainder. After you're done with that one, and notice I assigned the sign already. So plus. Now, the next number is just going to be the number. It's not going to have an x. So it's going to be 6. Plus, the next one is going to have x to the first power. Always. So, because they always drop down. If you start from the left side, you have to notice what the function was initially and subtract 1 and then follow the pattern. If you start from the right side, the answer is always going to be the same until you run out of values. So you go remainder, and then you go just a number, x to the first, x to the second. So over here, negative 5 is going to be 5x, negative, and then you write down the x squared because it's 1. Done. So with this one, there's no guessing. You just write down as you see it until you run out of values to assign x's to, which is actually easier. But again, if you do it this way or that way, it doesn't matter. You end up with the same result anyway. Okay? So that was synthetic division. I'm gonna wait for a few seconds here, so you could pause the video and copy this if you'd like. Alright, now let's keep going. Now, I'm gonna do another example, and hopefully with this we will get a few in for practice before the scheduled time for class runs out, because I'm trying to keep my videos under an hour, and the really long ones obviously going to be hour 20 minutes, but hopefully that way I time it to a lecture time so I don't give you guys too much too fast. Alright, so in this one, the function you're dividing is the following: x to the 5th minus 3x to the 4th plus 12x minus 33. Does that sound familiar? This is the same one we did in number 2 for long division. We solved this in long division above, so you already know the answer to this one. And we're dividing by x minus 3, right? Also, notice this is the fifth power function that you had a few missing. That's why I'm doing it, because I want to show you how to solve one when you have a few value missing. So over here we have fifth, third, fourth. I'm missing the third, I'm missing the second, and then I have the first and then the number, right? So I draw my box and I need to assign a value over here. My divisor is in the form of x minus what number? 3. That means it's a positive 3 that goes in here. If this was a plus, that makes this a negative, right? So since it's minus 3, it's a positive 3 inside that box. Now let's write down the coefficients. First one, x to the fifth, 1. Leave room. Second one, x to the fourth is negative 3. Yes? Next one, x to the third, I don't have it, so I'm writing 0. Next one, x to the second, I don't have it, so I'm writing 0. Next one, x to the first, which is 12, so I'm writing 12. And lastly, we have the number, which is a negative 33. Notice I grabbed the sign of each one. So make sure you maintain the sign. Leave room, draw a line. Okay, grab the first one, take it all the way down. 1 goes to the answer. Now we multiply. 1 times 3 is 3. The answer gets written right here. And then we add. Yes? So we add. Negative 3 plus 3 is 0. Correct? So 0 times 3 is 0. 0 plus 0 is 0. 0 times 3 is 0. 0 plus 0 is 0. Again, 0, and you end up with 12. Because when you add 0 and 12, you end up with 12. So 12 times 3 is what? 36. And when you add negative 33 and positive 36, the remainder is going to be 3. Right? Now, I need to translate what this means. I need to write it down. So if you want to start from the right, you can. And if you want to start from the left, you can. I'm going to do it from the left first this time, because last time we did the right first. So if you want to do it from the left, the right, we're starting with the 3, which is the remainder, and divided by the x minus 3. Since it wasn't technically divided yet, we're not done. Alright, so 3 over x minus 3 plus, since it's positive. Now, the 12 is going to be the number. After the remainder, first one is going to be the number. Plus, this is x to the first power. Since it's 0, I'm not writing it down. X to the first power, x to the second power, x to the third power, x to the fourth power, which is just 1. So it's going to be x to the fourth, coefficient 1. Done. Alright, now if I want to do it from the left side, I look at this one, and I go to the original problem, and I go, okay, so it was to the fifth, I'm dividing it by the first, it was to the fifth, now it's going to be to the fourth. So I go, okay, so that means it's x to the fourth. Next one is going to be x to the third, is 0, x to the second is still 0, x to the first is still 0, x to the 0, so it goes to 1, which means this is just the number 12. So you add 12, and then the 3, which is your remainder, so you add it, and don't forget to divide it by the x minus 3. Okay? And if you look at the notes we took before, this answer actually matches the question we solved previously. Alright? So there, that was a lot faster than long division. So synthetic is actually a lot easier, but you just need to get the practice in because it seems unfamiliar to you right now. But hopefully that gets better with practice. Alright? And, hold on. Did I pause for the first half? I actually don't remember, so I'm just going to do it anyway. Here you go. 1, 2, 3. So you can pause the video. And here's the second question. And now I'm going to remove my hand. 1, 2, 3, so you can copy if you want. Alright, all you have to do is pause the video. Alright, now, let's keep going. Oops. We're going to do one more before we move on to the theorems. Alright, so we have 3x cubed minus 48x plus 25x squared and plus 20. This is my function. Divide by x plus 10. Alright? Okay. So, there are two things you need to notice about this one. First one is that the value inside the box is going to be what? Since the form is x minus c, the fact that over here you have x plus 10 means that the 10 is going to be what? Negative in here, right? So, that means that this here is going to be negative. Now, over here, my function is going to be what? 3 is the first value you write down, right? So that's the cubed. Next, you need the squared. Oops, we don't have it. But wait, it's right here. So sometimes I could be sneaky and give you the function a little scrambled. You need to be able to tell if you have all your values or not. And I recommend reordering before you solve. So it only takes a second for you to do this. You just write, okay, 3x cubed plus the 25x squared minus the 48x and then plus the 20. Now you don't have to worry about messing it up, right? Okay, so now we go back to this. Cubed, we do have it, the coefficient is 3. For the squared, the coefficient is 25. So I'm writing the 25 down. It's positive. Now, for the first power, we have negative 48, so negative 48. And for the number, we have a positive 20, so positive 20. Yeah? Now, leave room. Draw a line. First number goes all the way down. Like this. Now we start multiplying. 3 times the negative 10 gives you a negative 30, right? The answer goes here. And then you add those. So, 25 plus negative 30 is a negative 5. Now, negative 5 and negative 10 multiplied together is going to give you a positive 50. And now you add them again. Negative 48, positive 50, they're going to give you what? Positive 2. And finally, 2 times the 10, negative 10, is going to give you a negative 20. And the addition between these two is 0. Your remainder is 0. This tells you that what you divided by is actually a 0 of the function. This is the solution of the function. That's why you have no remainder. It divides it neatly. Alright, so from here, again, you have the right side or the left side. You can start with whichever one you'd like. I'm going to do the left one this time since I did the right one last time. So we have 3, which is a coefficient of what? I need to go back to the function and look at it and go, okay, so it was cubic. Now, after I divide it by the first power, it's going to drop 1. So it goes to being a quadratic, right? So this is 3x squared. Next one is going to be x to the first. So minus 5x. And then you add the number over here. So 2 plus 0 since it's not there. So that makes this your answer. And if you do it from the right side, it's going to be 0. So it doesn't matter. Then 2 minus 5x and then the positive 3x squared. So same answer. Alright? So that was the synthetic division. Now I want to show you guys what the remainder theorem is and what it means. But since this video is already nearly at 50 minutes, I'm going to stop it and continue the section in a different video because I don't want the file to be too big to upload. Alright?